All right, so circle, ellipse, hyperbola, and parabola. I'm just going to quickly go over the standard forms, okay? The circle, it's going to be x minus h squared plus y minus k squared is equal to r squared. All right, that's with center hk and radius r. All right, with the ellipse, I'll do. You're gonna have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. All right, so when, and remember, a is always bigger than b. All right, and I'll do both. So you don't have to do both, but I'll do both. This is a horizontal ellipse. All right, if it's vertical, you will have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So that would be vertical. If you, yes.
There was like something that determined whether it was vertical or horizontal, like the number.
Yeah. So the term. So remember, x indicates horizontal movement, y indicates vertical movement. Whichever term has the larger denominator is what type of ellipse it is. If the denominator is larger under the y term, it's vertical.
How do you know if it's
If the denominator is larger under the x term, it's horizontal. All right? Okay, A is always going to be bigger than B. Okay? Remember, A is your semi-major axis, B is your semi-minor axis. All right. Okay? For your hyperbola, you will have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. In this case, this is a horizontal hyperbola. Horizontal. All right. And for a vertical hyperbola, you will have y minus k squared over a squared minus x minus h squared over b squared. One thing I want to note is that with hyperbolas, it doesn't matter whether a is bigger than b or b is bigger than a. What matters is what term is positive. If the y term is positive, it's a vertical hyperbola. If the x term is positive, it's a horizontal hyperbola.
I see which one is in front.
All right. So for the parabola, y is equal to 1 over 4p times x minus h squared plus k. That is a vertical. That's going to be a vertical parabola. That'll be normal parabola as a function. If your parabola is horizontal, then you would have x is equal to 1 over 4p of y minus k squared plus h. All right. So in general, your center is hk. All right. A is going to be your semi-major axis. B is going to be your semi-minor axis. All right, and that's for ellipses and hyperbolas. Yes, David?
After this, can you like help with 46 and 45 and 46 to solve the 0 less than equal to theta?
All right. So I'm gonna start doing conics, and then I'm gonna If I don't get to it, I'll post in the video. All right? Yes.
How would you determine if parabolas are positive?
All right. So if parabolas open up or down or left, right.
No, they're vertical and horizontal.
All right. So if the x term is squared, it's a vertical parabola. If the y term is squared, it's a horizontal parabola. All right. So those are the quick notes. If you need to get more extensive information, you're going to have to go back to your packets. All right. What is the center and the radius of the circle graphed by 2x squared minus 8x plus 12y is equal to 90 minus 2y squared? So what our first have to do is rearrange our x's and our y's. So we will have 2x squared minus 8x plus 2y squared plus 12y equals 90. Then we're going to have to factor out our 2. So when we factor out our 2, we will have x squared minus 8x, or x squared minus 4x. All right, and we could actually factor a 2 out of the whole thing, plus y squared plus 6y. Yeah, so you just divide by the whole thing by 2. That's perfectly good. 2 is equal to 90. Divide the whole thing by 2, so you have x squared minus 4x plus our complete the square term plus y squared plus 6y plus our complete the square term equals 45. Sorry, that's an equal sign. Plus both complete the square terms. All right, complete the square for the x term. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Add 4 to the first complete square term. 6 divided by 2 is 3. 3 squared is 9. Add 9 to both complete square terms. So that's a 4. Let me change my color. So this is a 4. This is a 9. Okay? This is going to factor into x minus 2 squared plus y plus 3 squared is equal to 58. 45 plus 13 should be equal to 58. 45 plus 4 is 49, plus 9 is 58, yeah. And then, so then you have a center at...
Wait, did we just put the 4 or we subtract the 4?
So, we add 4 to each side because we're completing the square. So we have a center at 2, negative 3, and a radius at the square root of 58. Alright, let's keep moving. What is the eccentricity of the hyperbola graphed by x minus 4 squared over 25 minus y minus 1 squared over 81? Okay? So with hyperbolas, so let's first about eccentricity. So these are two things we need to write down. Eccentricity is equal to c over a, and the Pythagorean relation for hyperbola that's 58, because 45 plus 4 is 49, plus 9 is 58. So the Pythagorean relation for a hyperbola is going to be c squared is equal to a squared plus b squared. And a squared is equal to 25, right? B squared equals 81. This is coming from our hyperbola equation. That's a squared, 25, 81 is b squared. So c squared is equal to 25 plus 81. The 25 plus 81 should be 106. So if c squared is equal to 106, c is equal to the square root of 106. If the eccentricity is c over a squared is 25, the square root of each side. A is equal to 5. So a is equal to 5, c is equal to the square root of 106. Our eccentricity is equal to c over a. So eccentricity is equal to the square root of 106 divided by 5. So eccentricity is equal to the square root of 106 divided by 5, which gives an eccentricity of 2.0. Let's just round up 2.06. Our eccentricity is approximately equal to 2.06. All right. So that is 60. 2.06.
What do you mean this class gets harder and harder? No. Math gets harder and harder. Yeah.
All right.
This is just easy.
All right. I'm going to start scrolling down.
Sounds like we friend chase.
I know.
All right. All right. So what is the range of the parabola graphed by y equals 2x squared minus 8x plus 1? All right. And our goal here is to get this into vertex form, okay? So what we can do here is we can factor out a 2, so we can rewrite this as y. Our goal is to get this into vertex form. Is going to be equal to 2 factored out of x squared minus 4x. And then we close our parentheses, and we're still adding 1. All right. Now, after that, we can complete the square. So we have x squared minus 4x. We're going to complete the square. So we're going to have y is equal to 2 times x squared minus 4x plus 4 and if we're adding 2 times 4 on the left side, we're going to have to add, and then this is obviously going to be a plus 1 here. We're going to have to add 2 times 4 on the right side. So remember, when I add a plus 4 here, all right, we add a 2 times 4 here, you can have a 2 times 4 on the right side as well. So plus 2 times 4. All right. So you'll have y plus 8 is equal to 2 times, this will factor into x minus 2 squared plus 1. We can simplify this into y is equal to 2 times x minus 2 squared. Subtract 8 from each side. It's going to be minus 7. All right. And just a heads up, I completed the square by doing negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Should have done that step. That's completing the square. So complete the square. All right. So I did that to add 4 on each side so I can get a perfect square perfect square trinomial so that I could get the parabola to vertex form. Want to know that our vertex is at, our vertex is going to be at is going to be at 2, -7. So our vertex is going to be at 2, -7. So remember, this is x minus h plus k. All right. So that means our range, if this parabola opens up, because our 2 is positive. So 2 is positive, so it's going to open up. So our range is going to be from -7 to infinity. All right. Another thing you can do is you can just take your calculator, mode, function, okay? Graph it, 2x squared minus 8x plus 1. You'd have to zoom out. All right, but if you did second calc, found the minimum, left bound,
It's a normal parabola. But yeah,
right bound, guess. All right, you would find the minimum was -2 or was 2, -7, and then that you could find the range that way. All right. I can do one more problem in before we're done. So let's finish. Let's finish conics before we're done with class. All right. So if the ellipse has a horizontal major axis length of 50, and that means 2a is equal to 50. If it has a vertical minor axis with a length of 48, that means 2b equals 48. All right. So if 2a is 50, that means a is 25. If 2b is 48, that means b is 24. All right. If the center of the ellipse is at the origin, so that means hk is 0, 0. What are the coordinate points of the two foci? So we know that. So we have a horizontal major axis. So that means that our foci are going to be horizontal. So our foci are horizontal. We know that a squared plus b squared equals c squared. So that means that c is going to be equal to the square root of a squared plus b squared, which means c is going to be the square root of 25 squared plus 24 squared. So c is going to be this should be the square root of 106. Let me check that. Wait. Swan. So sorry. Yeah. So c should be. Yes. All right. What? Let me plug it in again. A is 25. B is 24. All right. My fault. Here, I think I'm out of time, so I'm gonna do this in the next one. Yeah, so turn this in the second tray.